alaikum. Welcome to Teleclass Subject Forum. The purpose of this forum is to clear students' doubts about various subjects. So today we have chemistry as the chosen subject. To clear students' doubts, today we have here with us two very experienced teachers.
I'm the Ikram from Horace School, teacher chemistry and leading teacher. I have been in the field for past 12 years.
And my name is Ibrahim Walid. I'm Imaduddin School leading teacher and chemistry teacher as well. I have been in the teaching field for past 13 years.
And my name is Denina Ali and I'm here to conduct this forum with you all. And we have got some questions from the when I look at the questions, I see that mainly students has asked questions from three major topics, that is organic chemistry, chemical equilibrium and energetics, and also from redox. So to start with, I think it's we'll go with the organic chemistry. So I would like to pose the first question. What is the general formula of carboxylic acid?
The general formula of carboxylic acid is CnH2n plus 1 COOH.
Okay, the second question, in carboxylic acids, how many functional groups are possible?
In carboxylic acid, the functional group is there's only one fixed functional group, that is COOH, C double bond O single bond OH to be precise.
I want to add something. Actually, students get confused with the functional group of carboxylic acid and alcohols because both the structure contain OH group. Actually, in carboxylic acid, that there is C double bond O bond, but in alcohol there are no that bond. So you'll be able to distinguish from alcohols and carboxylic acid from that bond only.
Okay, then the next question says if a compound structure is congruent, but one is a mirror image of the other, is it still isomeric?
Now, that question is somewhat that is related to A level as well, because in O level we learn isomers as compounds that have same molecular formula but different structural formula. When we talk about the structures that are isomers, there's something called the trans and cis type of molecules, which is little bit A level concept. So it's better to stick on the O level for at this level and stick on the definition of molecules with same molecular formula but different structure.
Also, it's better to use the syllabus, right?
Yeah.
So those students who are in grade 10, it's always advisable to use their syllabus so they will not get confused with other some complicated concepts, right? And then I'll move to the next question. What are polymers?
Polymers are actually formed by joining many monomer units. So in this level, we have two types of polymers, that is addition polymers and condensation polymers. First of all, students should know by looking at the monomer structure that what kind of polymer is that going to form, whether it is undergo addition polymerization or condensation polymerization. So in addition polymerization, the monomer should contain carbon-carbon double bond, but in condensation polymerization, the monomers will have different functional groups.
Let me add one point to that. In their syllabus, when they talk about polymers, they will be highlighting natural polymers and synthetic polymers as well. Synthetic polymers, that is being the polymers that is usually made by people, human beings. So usually synthetic polymers, most of the examples like polythene, they are made in addition polymerization. That means something that contain carbon-carbon double bond is used. In all addition polymerization, the reactant is an alkene, that is carbon-carbon double bonds, a molecule that contain carbon-carbon double bond. But instead, when we talk about natural polymers like carbohydrates, proteins and fats, these structures are formed by condensation polymerization. Usually there is combination of two different monomers that has different functional groups. So for example, when we talk about fats, how fats are formed, usually something called glycerol plus fatty acid is used. Fatty acid means it contains acid group, and glycerol, as in the name itself, it ends with OL, means it is an alcohol. But the thing is, it's a unique alcohol that contains 3 carbon, 3 OH. In every carbon there's only 1 OH, total to 3 OH. So it's a combination of two different monomers. Monomers means reactants to form a polymer. So usually it's always best to remember, usually natural polymers, they undergo condensation, and synthetic polymers, usually it is addition polymerization. Of course, there are other examples in synthetic polymers like nylon, terylene, which are condensation polymerization. Yes.
Is it possible for you to show one of the polymer formation?
Okay.
So the simplest form of addition polymer, if you take an example of an addition polymer, the simplest form is we called polyethene. Usually when we write the name of the polymer, the one that is next to poly inside the bracket is the name of the monomer. So that means polyethene is made from ethene, which has 2 carbon and carbon-carbon double bond and 4 hydrogen. And when carbon-carbon double bonds are broken by reacting with other ethene molecules, the final product we get is the polymer structure. So we draw the 2 carbon that is having the double bond. We introduce the hydrogen bonds to up and down of the molecule, and then we introduce the continuation line. That means that one ethene molecule, as it's mentioned here, it is continuous for both sides. We introduce a bracket, and then we use N in order to represent that this structure can be repeated to N times, or N should be a whole number. Okay.
Okay. Formation of polyethene, I think it's clear. And also, like, what happened to that double bond over there?
The double bond is broken when it reacts with other ethene molecules. So it is small molecules joined together to form a long chain reaction.
Okay. And are fats polymers?
Yes.
Right. Then we move to the next question. Can you explain more about how to name alkanes? What is the technique that we need to learn here?
Okay. First of all, students should know the sounds that start in sound of each carbon, number of carbon in the molecule. For example, if it has a 1 carbonate, it's meth. So meth, methane, methanol, set the sound of the 1 carbon compound. If the carbon contain in 2 carbonate, if the compound contain 2 carbon atom, the sound would be eth sound. So it is ethane, ethene, ethanol, and ethanoic acid. Then if the carbon contain in 3 carbon atom, it is prop, the sound is prop. So propane, propene, propanol, and propanoic acid. So based on the number of carbon atoms, students should be able to understand the sound first of all. So actually alkanes contain the suffix A-N-E.
So likewise they can learn, right?
Yeah.
Okay. Um, okay, the next question here it is, can you explain cracking of hydrocarbons?
Cracking, cracking is a process that need to be done because it is followed by another process. The idea is about fractional distillation of petroleum or crude oil. The reason why we do petroleum fractional distillation of petroleum is we get different chemicals from it, different fractions from it. But the fractions we get from that process, small amounts are the smaller molecules. For example, petrol, refinery gas, we get in a small quantity. But the larger molecules like fuel oil, which is used in less area in our everyday life, or which has less demand. So the problem is there is high demand for smaller molecules. So we need to find a way to produce more smaller molecules than the larger one. So in order to meet the demand, cracking need to be done. So the idea of cracking is we crack large hydrocarbons that we get from petroleum, from the fractional distillation of crude oil, and change into smaller molecules. By subjecting these molecules into high temperature and using a special catalyst called zeolite, which is combination of aluminum oxide and silicon dioxide. Usually we can use aluminum oxide as well alone. We can use silicon dioxide alone as well as a catalyst. So at high temperature, these larger molecules are broken down into smaller molecules, specifically alkanes and alkene molecules, which are useful. Yes.
Right. Then it comes to another question saying that this has got 3 carbon atoms in between all double bonds, and asking whether this is an alkene or something else.
Of course, that's an alkene because the general formula of alkene or the functional group of alkene, it contains double bonds. So if there is a carbon double bond, there should be an alkene.
But I think they are asking about like if it is an alkene, the general formula we say CnH2n, right? But for this it won't fit if there's many double bonds.
Even if there are many double bonds, it's still alkenes,
yeah,
because it contains carbon-carbon double bonds.
Then
so
we name like diene, triene,
yes.
Yes.
likewise.
The
Right?
thing is, if it contains more than one carbon or double bonds, then it may not follow the general formula. But it goes into the idea of diene and triene, yes.
Would you mind showing a diene? Maybe students would need to be more clear about. That's how the structure.
So when we draw the structure of an alkene, usually it has only one carbon-carbon double bond.
Okay.
This will be the single bonds will be the carbon-hydrogen single bonds. But if you draw the structure of a diene, then it contains 2 or more double bonds. That means the number of hydrogen may differ. So as you can see, this one, it has 4 carbon and hydrogen, 8 hydrogen. But the number of hydrogen here is less because each carbon can accommodate maximum and minimum 4 bonds. So when we introduce carbon-carbon double bond, number of hydrogen will be less. Okay?
Good.
Right. I hope it's clear. And The next question is, what are homologous series?
Shall I?
Okay.
Okay. Homologous series is a series of compounds with which has the same general formula, same functional group, and it has a similar chemical properties, and it has a gradual change in physical properties, and each member differ by next member by a CH2. So this is a quite large definition, but still students should remember all the important point of this definition.
Yeah, can I add one thing? So when we talk about homologous series, think about this as we are forming a chain. A chain will start with one block of chain. Then that will be the simplest structure of that family. A homologous series is usually it's a family of compounds. By joining what we call this number of carbon, we call chain of carbons. So each two molecules, they differ with CH2, which means one carbon and two hydrogen. For example, if we talk about methane, it has CH4, but when we talk about ethane, it is C2H6, which means one carbon and two hydrogen is increased compared to methane, and it goes on like that.
And what is meant by the term saturated?
Saturated and unsaturated. Saturated compounds does not contain double bonds, but unsaturated compounds, it contains double bond. It could be carbon-carbon double bond, or if there are other double bonds, even it goes unsaturated compound. So in O-level context, actually we refer alkenes are unsaturated compounds because it contains carbon-carbon double bonds.
Actually, saturated, it's one very important point, saturated and unsaturated, because it is usually repeated in the past paper. So it's a very important point for students to remember. And they will also need to know how to differentiate by using a chemical test, whether something is saturated and unsaturated. And the most common answer will be bromine, aqueous bromine. When bromine is used, the one which is unsaturated will change the bromine color. The other one that is saturated will not change the color.
Yeah, that's actually the next question.
Yes.
So I hope it's clear now how to identify saturated and unsaturated compounds. That's by using aqueous bromine water, right? Okay, I think it's all. No, there's one more. What is flammability?
Flammability is ability to catch fire. So flammability differs as when the carbon number increases, when the carbon chain increases. So smaller hydrocarbon molecules, they have more flammability, means they can catch fire more easily than the larger hydrocarbons.
Okay, then it says explain redox reactions.
Yes, redox reaction is actually a very common question that many students feel that they confuse, because in order to define redox, you have to define two more concepts. A redox reaction is a reaction in which oxidation and reduction take place at the same time. Now, when we talk about oxidation, to define oxidation, there's 4 key points that they can use in order to define. And similar way, the exact opposite of oxidation is reduction. So in order to define oxidation, they will need to learn, students will they will need to learn in terms of hydrogen, in terms of oxygen, in terms of electron, and in terms of charge, that is increase in charge, or sometimes called oxidation number, also called oxidation state. So in terms of electrons, a reaction, if electron is lost, we say it is an oxidation reaction. Or if oxygen is added, then it is an oxidation reaction. Or if hydrogen is removed, then it is an oxidation reaction. Or from reactant to products, if oxidation number increase, then we say it is an oxidation reaction.
Yeah.
The exact opposite will be the reduction.
Would you like to
Yeah.
give an example?
Yes, sure.
And also it will, also students like to know what are oxidizing agents, what are reducing agents. So in your example, if you can include that.
Okay, I'm going to explain with an example of redox reaction. This is a very common reaction called metal displacement reaction. When copper sulfate react with zinc, copper. Okay, this is a very common metal displacement reaction as a redox reaction. So, what are the reducing agent in the reaction and what are the oxidizing agent in the reaction? So, first of all, students should be able to know which substance going to oxidation and which is going to reduction. So, the easiest way to identify the oxidizing species is to know the oxidation state of that element. Okay, in copper sulfate, what is the oxidation state of copper? That is 2+. What's the oxidation state of zinc here? Zinc element, it is 0 because all element will have the oxidation state 0 in their element state. So, this is 0 and here the oxidation state of zinc is 2+. And here the oxidation state of copper is again 0. So, what is happening to the oxidation state of copper? It is being decreased, okay, from +2 to 0. So, the oxidation state of copper is being decreased, reduced from +2 to 0. That means copper is going reduction. And what has happened to the zinc? The oxidation state of zinc is increased from 0 to +2. So, zinc is being oxidized. So, in terms of oxidation state, we can explain this question that this is the redox reaction because copper is reduced and zinc is oxidized. So, in this reaction, there is oxidizing agent as well as reducing agent. So, what is the oxidizing agent here and what is the reducing agent here? So, zinc. Okay, zinc is the species actually which reduces copper from 2 to 0. So, zinc is the reducing agent here, reducing agent, and copper would be the oxidizing agent. So, in a redox reaction, the both way is there, the reverse. So, you should be able to understand from both direction. That's it.
So, reducing agent is the one which helps to reduce the other substance,
Yes.
right? And vice versa, oxidizing agent, right? Okay, and also students asking what are reversible reactions?
Maldives, can you explain?
Yes. Thank you. Yes, I'm going to explain what a reversible reaction. In order to know the concept, you have to know a very common symbol that you might have seen before. This is called the reversible sign. This is where a reaction, for example, let's take nitrogen and hydrogen as an example. When nitrogen and hydrogen combine, it forms ammonia. Now, all these substances, they are gases at room temperature and pressure. So, meaning they can be existing in a container, in a closed container, where you will not know whether the container is containing more amount of nitrogen or more amount of ammonia. A reversible sign is where the combination of these nitrogen and hydrogen produce ammonia. At the same time, the ammonia breaks to form hydrogen and nitrogen. So, it is a reaction in which both forward reaction and backward reaction happens at the same time. That's a reversible reaction.
So, students need to learn about this symbol, right? The reversible sign whenever they have to write a reversible
Yes.
reaction that they have to use.
And also that symbol, yeah.
Yeah. Do they need to learn all this by heart, or is there a technique?
And also it's very important to balance the chemical
Balance the
equation.
chemical equation. This equation is not
especially in
balanced.
reversible reactions.
Yeah. Yeah, because one student is asking how to learn chemical reactions. I mean, yeah, could you?
Chemical reaction actually, it's very abstract thing. You may take several days actually to learn chemical reaction. Even one lesson, some students can get the chemical reaction, but you feel that chemical reaction is very difficult thing that you will not learn at all. So some students even give up with the chemical equation, that they think that they will not learn chemical equation at all. But gradually, the knowledge will develop gradually only. So it is not possible in one or few lessons that you will be able to write the chemical equation. So it will take time actually, but lot of practice even.
Can I add something? In order to start a chemical reaction, I think one thing that you can start is categorize chemistry into two. One is inorganic and
Okay.
organic.
Yeah.
And if we talk about inorganic, you can the students can draw a mind map. The inorganic compounds, usually they have reactions where two compounds join to form products, or one compound breaks down to form products. So you have two categories now. The first category is inorganic chemistry. The second category is where two or more compounds combine to form products, where one compound is broken down to form products. Then you can identify those two compounds or two or more compounds that are reacting. So the most common type of two compound is acids and bases or salts. These are the three main compounds. Usually it can be an acid, base, salt. If it is not a compound, then it will be an element. Element, you can deduce the information from the periodic table. So it is a combination of the idea of periodic table and bonding. That the first thing is you need to learn about the periodic table. It's very important. Once you know about the periodic table, then you need to learn about how to write the chemical formula. And then once you learn how to write the chemical formula, you need to know how to learn to balance the chemical equations. And when you go towards the equation, then you can categorize what kind of equation is this. Is it acid-base reaction, or is it acid-metal reaction, or is it metal-water reaction? You can categorize these reactions in different order.
So it's
Yes.
not an easy thing, right?
Yes.
With a lot of practices,
Yes, a lot of
Ikram sir
practice
has
will be
said it
needed.
will take, right? Okay, we'll take a break now and we'll be back soon. Okay, welcome back. So we'll continue with more questions. We have got some more questions again from students. Like the next question, it says, what is equilibrium and what is dynamic equilibrium? Can you explain the difference between these two?
This is very important definition. What is dynamic equilibrium? What is a dynamic equilibrium? So it happens only in the reversible reaction, the dynamic equilibrium. So when in the reversible reaction, there will be both forward and backward reaction, right? So when the rate of both forward reaction and backward reaction is equal, so that during that time the concentration of the reactant and products remains unchanged. So that is called dynamic equilibrium. They are very two important that students should understand. And while answering this question, rate of forward reaction and backward reaction. Okay, some students actually forgot to write the word rate. So if there is not that word, actually the marks will not be given for that question.
Then it says, what is displacement reaction?
I think before Ikram also mentioned while he discussed about the redox oxidation state, a displacement reaction is a reaction in which an element reacts with a compound. So always there will be an element and a compound. The element, if the element is more reactive, then the element will displace the element inside the compound and form new compound. So, a more reactive element displaces a less reactive element from its compound. That's a displacement reaction.
I want to give one example on that. There are two types of displacement reaction that a student should know from the syllabus. That is, one is metal displacement reaction, as I have explained before. And the other type of displacement reaction is halogen displacement reaction. In this one, more reactive halogen is displaced, less reactive halide ion is being displaced by more reactive halogen. For example, bromide ion from its solution can be displaced by chlorine.
Okay, so that's about displacement reactions, right? Now, there are some more questions, but I would also like to, because from our experience, we have seen that students find it difficult to differentiate between the electrolytes and conductors, and why conductors conduct electricity and like electrolytes when how it conducts electricity. So can you highlight on
Okay.
this?
First of all, what are electrolytes? Kiwegento wake substance me bunani electrolyte eke. How it become an electrolyte? Kodokondi explain called there. Electrolyte vejia ega honanje free ions. Okay, it could be hama electrolyte with an acid noni ionic compound in solution or in molten state. So electrolytes are ionic compound in solution or in molten state which contains free moving ions. So acids are also electrolytes and also ionic compounds in their molten state or when they are dissolved in water are electrolytes. So it contains free moving ions, electrolytes.
Can I add?
Yes.
In my experience, many students have come across this question that why organic compounds they does not conduct in solid state, but they conduct in aqueous or molten state. And usually the answer many students write, I have seen, is because the electrolyte or the ionic compound does not have free mobile electrons. So they confuse ions and electrons in terms of the electrical conductivity. When we talk about electrolyte or ionic compound, always the answer should be mentioned in terms of ions, and electrons should be mentioned when we talk about a conductor which is a metal. It should be a metal, and non-metal there is only one example, which is graphite. Only those cases they will need to mention the free mobile electrons. All other cases, whether it is an ionic compound in molten or aqueous, they need to mention they conduct electricity because they have free mobile ions, not electrons.
So is mercury an electrolyte?
No.
Which is in liquid state?
No.
Metal.
It is a metal in liquid state, but it does not contain ion. It contains free mobile electrons. So it is not an electrolyte, but it is a conductor because it conducts electricity since it has free mobile electrons.
Then when the question comes about kinetic particle theory, like many students lose marks because they are not able to write all the points that is required. What are the things that students need to know when they write answers on kinetic particle theory?
Okay. Usually the question asked in this way. So explain in terms of kinetic particle theory how solid melts.
Yeah.
In students' answer, there should be a sequence. What is the first point and what is the next point, so on. So first of all, when the solid is heated, the solid particle, they should know about the arrangement and the movement of the solid particle. First of all, those points should be mentioned in the explanation. When the solid particles are heated, they start vibrating faster because they have more kinetic energy, and the adjacent molecules are being pushed, and it creates a space between the particles, and so it melts. Actually, marks are being lost because there are no flow the sequence, that the answer should have a flow, and also some important points like arrangement. The question ask about the explain in terms of the arrangement and the movement of the particles. So if the question asks about those points should be explained in the answer. It depends on the question.
So are you saying that kinetic particle theory, it's about movement and the force of attractions?
Now, I will add some points. Kinetic, even in the name itself, it says kinetic particle theory. So kinetic means, usually kinetic means movement of particles. So in order for the particles to move, or if we write a theory about the movement of particles, if we deduce a theory, the movement should be there, yes. But mostly the movement is usually because of its arrangement as well. So this movement and arrangement is linked with the energy transfer. So those 3 points actually need to be there. That is movement, arrangement, and the energy transfer while change of state or in any situation. So as Ikram mentioned, it's very important to mention the arrangement and the movement of particles before the change of state and after when they change of state.
Okay, it's about question paper, I think. In IGCSE paper, will the periodic table be provided?
Yes.
Periodic table will be there, yes.
For
all the
MCQ
papers?
and the theory paper, not for practical paper. It's
Yes.
not required for practical paper because any mass number or atomic number, it will be given in the questions itself.
Now,
Practical.
me mentioning about the periodic table. The paper 4, they will not have periodic table, yes. If they need the periodic table, that will be, usually students need to refer the mass number. So the mass number will be given in the question for paper 4. But the problem many students face is when they are to write equations, without looking at periodic table, they may not know to deduce the charge of a specific element. So I advise my students always, it's best to know the first 20 elements group number, and once you know the group number, it's better to know the charge that once you know the group number, you will be able to easily deduce the charge or the valency of that element. So you don't need to learn everything in the periodic table, but there are some key points. That's the elements, the first 20 elements group number. If you learn, then that will be a very big help for paper 4.
And regarding period table, in our previous syllabus, 5070, in that syllabus actually the mass number is given as the top number,
Yes.
but now it is different now in CIE, IGCSE papers. So students might get confused because we have 2 types of period table now. Sometimes the teachers, actually some teachers, they provided the period table from the older syllabus.
syllabus.
So I recommend this time for all the teachers, provide them the recent one.
And also students to look for the key, right?
Yes.
So that they will not get confused. Okay, then the next question is says, is it necessary to balance the equation whenever they write the chemical equation, even if the question does not say so?
To be on safe side, it is necessary actually, because we have to be on safe side. I don't know actually what the examiner expect from us. So if you know how to balance it.
I always mention that to my students. An unbalanced equation is a wrong equation.
Yeah.
So always focus on writing, whenever you write an equation, make sure write the correct formula first, and then after that check whether the equation is balanced or not.
Okay, one more question from organic chemistry. What are branch chain alkanes? Branch alkanes, I think. Maybe if you can show.
Draw.
Board. You're familiar with the board.
Can just flip.
Alright, the question is to explain the idea of branch alkanes.
You can take propane.
All right.
So butane is
The idea of
Butane.
branch
Yeah,
alkanes.
butane.
So let's take an example. Butane. Butane has 4 carbon and 10 hydrogen. This is the molecular formula of butane. And if you draw the linear structure, you will have 4 carbon, each carbon bonded, single bonded to hydrogen in this manner. Now, if you start from one end to the other, you will come across only hydrogen elements in this molecule. But if you represent this structure in a different way, this is a molecule that contains branch, which means if you start from one end and if you move to the other end, you will come across one carbon-carbon bond. And if you change the route, if you start from this side and if you go to the right side, then there will be again this branch as well. And if you change the route from here to here, then you will come across this carbon as the branch as well. So a branch alkane is an alkane when you start from one route, you will come across another carbon that is coinciding with that route. All right, a linear structure will not be in that
I have
manner.
a question. Can that branch be on the last carbon?
Not possible. If you, as I mentioned before, if you draw to the last carbon, for example, you have 3 carbon, and if you draw the branch on the last carbon, then you can move from this carbon to this carbon without meeting any carbon-carbon single bond. That means there is no coinciding with any other bond other than only hydrogen that you will face. And you
Okay.
can move in one route.
That means
Alright.
the branch should be middle, right?
Yes,
Yes.
branch should be always starting from at least from the second carbon. In this one there is only 3 carbon, only second carbon is the middle one. So in any other structure, always the branch should start from the second carbon. Okay.
Okay. The next question is, what happens in substitution reaction of alkanes with halogens?
Substitution reaction. This is very important reaction in because this is the one of the important reaction in alkane. In alkane there are 2 reactions actually, combustion reaction and substitution reaction, because only these 2 reactions are specified in alkane part. Okay, I will draw. Red mark. Okay, this is what happened in substitution reaction. Halogen atom is being substituted by a hydrogen atom. It's being replaced by a hydrogen atom. So one of the hydrogen atom is being removed from the structure, and from a chlorine molecule, one of the chlorine molecules being substituted. Okay, it's being removed. and the remaining, when this hydrogen atom is being removed, it is forming a bond with the another chlorine molecule and forming HCl. There is very important condition in this reaction, because this reaction occurs in the presence of UV light. In the presence of UV light only, when that chlorine molecule split into chlorine atoms. And the other reaction of alkane is combustion reaction, where alkane reacts with the oxygen forming carbon dioxide and water in complete combustion, and in incomplete combustion the product will be carbon monoxide and water.
One explanation for substitution can be, students will be easier to remember if they think about football. In football, one player is substituted with another player. So in a substitution reaction, one element from the molecule is substituted by or replaced by another element from another molecule. So you can think alkanes as a football game in that manner. So one element replaced by another element.
Yeah. And the other question is, will there be skeletal formula to draw in IGCSE? And if there is, can you explain what are skeletal formulas?
I have not come across such question in IGCSE O level syllabus.
That's not in the syllabus.
Then what's the difference between displayed formula, molecular formula, and structural formula?
Okay, displayed formula and molecular formula. Some students get confused with the displayed formula and the structural formula. This is very important in alcohols and carboxylic acid especially, because displayed means you should display all the bonds in that compound in the formula. But structural means you should not, it's okay even if you do not show all the bonds. For example, I can show you one example of a displayed formula. Okay, this is ethanol. All the bonds of ethanol is being shown, right? Even the OH bond is being shown. So this is displayed formula of ethanol. So if the question specifically asks about the displayed formula, you should show OH bond like this. But this is also a structural formula. You can draw the structure without showing. You can even draw this formula without showing the bond in the OH part. Even this is a structural formula. All these are structural formulas, but this is the only displayed formula because all the bond in the structure has been displayed.
Right. The next question is says, is graphite and fluorine different elements? Does it contain different elements?
Yes.
No, it is the same element. It's the same element. Both contains carbon atom, but the structure is different. Graphite has carbon which is arranged as a hexagonal ring structure forming layers, and there will be one electron free from each carbon atom. Those electrons are free. This way graphite can be used as the lubricant, also as a conductor. But fluorine actually is limited by 60 carbon atom forming a hexagonal ring of ball-like structure.
Yeah. Okay. Then are details of carbon nanotubes required in this syllabus? I think
Details of carbon nanotube,
Not details.
there might be a question, okay, because the structure of carbon nanotube is very similar to the structure of graphite, because the carbon nanotube also having the same structure as graphite, hexagonal ring structure, and as well as there will be a free electrons. So there is a similarities between the structure of graphite and the carbon nanotube. So there might be an application question regarding this.
Then the next question says, how do I identify state symbols, especially if the compound is aqueous?
you should be able to, students should be able to know the solubility rules.
Uh-huh.
Like all nitrates are soluble, and most of the carbonates are insoluble except for group 1 carbonates and ammonium carbonates. So that is very simple thing. Super salts, SPA. So super salts are soluble salts, means sodium, potassium, and ammonium salts.
Yeah.
So all these salts are soluble. So simply you can remember super salts. Sodium, potassium, and ammonium salts are soluble in water. Most of the carbonates are insoluble, and most of the hydroxides are also insoluble. So there is a rule. So it is limited in O-level syllabus. So the required thing, actually teachers usually provide students what are the soluble salts and insoluble salts the student need to remember. And there are very important things like barium sulfate is insoluble white precipitate forms, and silver chloride, silver bromide. These actually come in the test for iron table. So those all precipitates, whenever precipitate comes, those are solids.
So if it is solid, they right?
Let me add one
Yeah.
point. The solubility rule is mainly for salts. So if they have to know the solubility of any salt, then they need to learn the solubility table. In addition, they need to learn the state symbol for acids and bases as well. Mostly acids are something that dissolve in water, that means they will be aqueous. So that will be easy part. But when it comes to elements, most students confuse. Elements, they need to learn the properties from the periodic table. So for group 1 elements, almost all metals, they are in solid state except mercury. So when they react with other substance, what happens to the state symbol depends on the reaction and properties. So they need to know the group properties in order to learn the state symbol for elements. For compounds, they need to learn acids, bases, and salts. That's the main idea. Yes.
Yes, I think this is the last question which we have got here. How to know, how to find out oxidation state, oxidation numbers? Maybe asking about how to calculate or oxidation numbers.
Okay. There are two ways actually we can get the oxidation number from the periodic table itself, because all group 1 elements will have the oxidation number, or the valency we call oxidation state +1. All group 2 ions will have +2, right? And group 3 it has +3. So we can get the oxidation state of some elements or elements from the periodic table, but for compounds we have to do a calculation. Can you do that?
Yes.
Okay, good.
So the question is to calculate
Yeah, we can use
the
carbon dioxide.
oxidation number.
Simple one.
Yeah. For simple compounds, for example, carbon dioxide, we have to know the oxidation number of oxygen. We can deduce from the periodic table that it is group 6. So that means the oxidation number of oxygen will be -2. The idea of calculating oxidation number for the element is we represent X for the one which we are finding. We add the oxidation number. If we have 2 oxygen, we multiply by 2, and since this is a compound overall charge will be 0. So overall charge will be 0. And now we have a linear equation, algebraic equation, which means if you multiply -2 times 2 will be -4 equals 0. So when you bring -4 to the right hand side, it will be 0 plus 4, which means the oxidation number of carbon is +4. It's very important for the students to mention plus. If it is a plus charge, mention the plus, or if it is minus, mention the charge, because if you mention only the numerical value, the answer will be wrong. So that's the main idea, how to identify the oxidation number.
Okay, thank you teachers for participating in this forum with us today. Then come on, वरम उफ़ावे जाएंगे तो टीचर्स बदलती कुदिंगे होरी हाँ डाउट्स तक मियदा हमें लिपे पहरे गिना सवाल तक हम टीचर्स जवाब देवी जक हम ही करम then इतुरवे सम क्वेश्चंस ता देंगने सेशन ने देंगने फोरम में हम तिको दिन गे डाउट्स तक क्लियर कर देवो टीचर हम गेंदवान ये तो एम मियद के सेशन का आदि से फॉर बैवर में देवे थी इकरम से आदि वाली से वरम बड़ा शुक्रिया शुक्रिया
शुक्रिया
अस्सलाम वालेकुम